Hey, this might not be the prettiest video in the world, but I'm going to answer some questions that I think Judah put on the help board. So let's start with number 16. And I'll try to go as quickly as possible. Just having a little trouble with my app right now. It's not letting me pick a color. It's letting me do smiley faces though. There we go. Okay. So I think I'm going to work in red so I can write on both the blackboard and the white part. Sorry about this. Okay, so number 16, it says the measure of angle ALS minus the measure of angle 2 equals the measure of what angle? So you go up to the drawing up here. Sometimes it's hard to tell which drawing goes with the problem. But this one says it's for exercises 1 through 18, so that's your first clue. Okay, so we have ALS. ALS. That's the big angle right here. You could also call that angle L if you wanted to. Minus angle 2. This one is angle 2 right there. If we take that off, we're left with ELS. So it'd be angle ELS. Right? So if you have the big angle right here, you take away this partial angle, it's left with this other angle right here, angle ELS. Okay, number 17. If measure of angle 1 equals the measure of angle 2. Now we mark the measures. I'm just going to erase this so we can have some more room. So if this is ELS. Okay, so measure of angle 1 is equal to measure of angle 2. So we mark our angles like this to show that they're equal. Then blank bisects blank. Well, it's right here. It's segment LE. This one is bisecting, which means cutting it in half. So we would say segment LE bisects angle, you can put a line over that for segment, bisects angle, and it's the big angle again, ALS. That's the angle that's bisected, so when it's divided into two equal parts, it means that this is bisected, and it's bisecting this big angle right there. Okay, so that was 16 and 17. The next one was 18. 18 says if, right here, if measure LDA, so LDA is this one right here, LDA plus ADE equals, well, they're called a linear pair because they lie on the same line. And if two angles lie on the same line, they share a common side. That's 180 degrees. So that's that one right there. Okay, the next one is, we're jumping down, not too far, 23. I can pull this up a little bit. Whoops, no I can't. Forget that, because I have writing on the board. Okay, but I can scroll down. Okay, so number 23 says, in the plane represented by your paper, how many lines can you draw through O that will form a 30-degree angle with OB? So let's just draw OB. It would look like this. It's a ray, so we call it ray OB. So O, and we need another point on the ray, B. How many lines can you draw through O that will form a 30-degree angle? Well, that is, we can do two. We can draw one this way that will make a 30-degree angle, and we can draw a line this way that will form a 30-degree angle. So the answer to this one is 2. So this would be 2. And the next one, in the plane represented by your paper, how many lines can you draw through O that will form a 90-degree angle? So let's just stay with this. If we're going to form a 90-degree angle with OB, there's only one line that you can draw right down through here, will form a 90-degree angle. So that is the same line, so the answer to this one is just 1. You wouldn't have, it's not asking how many rays, it's asking how many lines. So this would just be one line forms a 90-degree angle with OB, ray OB. Okay, the next one is 27. This one's a little complicated. It says the measure of angle 2, measure of angle 3, express the measure of angle 2, measure of angle 3, measure of angle 4 in terms of t when the measure of angle 1 equals t. All right, this is a little different terminology. So if it says express in terms of t, it means t is going to be your answer. So let's start with the measure of angle 2. The measure of angle 2, if you note, 1 and 2 lie on the same line right here. So 2 is going to be 180 degrees minus t, because t and angle 1 are the same. So that's how we're writing it in terms of t. So this is t degrees, basically. All right, measure of angle 3. All right, these are vertical angles, and vertical angles are, the measures are equal, so angle 3 would equal t. They're the same. This is also t degrees. These are called vertical angles, and they're congruent. All right, and the last one is measure of angle 4 is going to be the same as measure of angle 2 because they lie on the same line A. So 1 plus 4 have to equal 180 degrees. So 4 is going to be 180 degrees minus t. So that's a little tricky. It's probably something you haven't experienced before, writing things in terms of a variable. All right, a careless person wrote, using the figure shown, that the measure of angle AOB plus BOC equals AOC. Now the problem with that, according to our angle addition postulate, is that B must be on the interior of the angle. And this angle here, right here, B would have to be here for that to work. But B is not in the interior of it, so it doesn't work according to the angle addition postulate. Okay, quickly, let's go on to the next group. All right, the next group was 29 to something, so let's just do a few of these. I think once you see how they're done, you'll get the hang of it. So this one says the measure of angle 3 is 6x. So I'm going to fill these in on the diagram, and then I'll just erase it every time. You can kind of do that in your book too, or you can recopy it. So the measure of angle 3 is 6x. That's there. The measure of KAT is 90 minus x. This is 90 minus x. We're supposed to find x. Now we know that this angle right here and this angle right here lie on a straight line. They're a linear pair, so they have to add up to 180 degrees. So I'm just going to take 6x plus 90 minus x equals 180 degrees. So it's going to be 5x equals 90, and x is going to give us, I didn't do these ahead of time, so bear with me, 18 degrees, or 18. X equals 18. So see how that works? If they're on a linear pair, on a straight line, they add up to 180 degrees, and you solve it for x. So I'm just going to erase all this as we go so that we can, I can use the same drawing over and over again. So this first one's going to be 18. All right, let's just talk through some of these. The measure of angle 1 is here. The measure of angle 2 is right here. They want us to find the value of x. Oh, this is, I forgot this. AL bisects KAT. So KAT is this angle, and this AL bisects it, means that this is equal to this. So since they're congruent, we can set their measures equal to each other. So I'm just going to say 7x plus 3 equals 6x plus 7. So I'm going to subtract 6x from both sides, so you get x equals 4. Subtract 3 from both sides. So that answer is 4. So we get 4 there. All right, the next one says measure of angle 1 is 5x minus 12. The measure of angle 2 is 3x plus 6. This is exactly the same as the number 30. You're just going to set these two measures equal to each other because it says that this bisects it. Measure of angle 1, moving on to 32. Measure of angle 1 is x. Measure of angle 3 is 4x. Phew, okay. This one's a little bit different. This one is x. Measure of angle 3 is 4x. And we also know the measure of angle 2 because since this ray bisects it, this one is also x. So we would say 4x plus x equals 180 degrees because these three angles all lie on a straight line. So we would get 6x equals 180, and we would get x equals 30. So that is that one. Let's see if anything's different here. Okay, so this one would be 30. And let's see what the last one is. Measure of, I forgot to erase all this. Okay. Measure of angle 2 is x plus 12. The measure of angle 3 is 6x minus 20. So this is the same as 33, a little bit harder. Measure of angle 2 is x plus 12. That means the measure of angle 1 is x plus 12 because they are congruent. And measure of angle 3 is 6x minus 20. So this one you would add these all up equals 180. Okay, let's move down to the next part. Now, when you're hitting C problems, I don't want you to panic if you can't get the C problems. These are definitely very advanced. They'll probably show up on your test as extra credit problems. So you want to try to do them in case they show up on a test, but if you can't get them, don't panic. So I'm not even going to do these. This one right here is the biggest bugger in the world. I spent a lot of time getting this one, and to explain it, it just takes so much work. So you can look on the Slater. Slater.com has all the solutions, and you could try to work yourself through Part C. So I'm going to end the video for right now so it doesn't get too long. So if you have any more questions, please put them on the communication board and I'll try to answer them. All right, that's it.